Okay, great. Well, thank you for joining the OHCS Multifamily Energy Program. This training on a multifamily overview of the 2019 Oregon Zero Energy Ready Commercial Code. The Multifamily Energy Program offers energy efficiency technical assistance, support, and incentives to new construction and retrofit projects serving low-income Oregonians. I'll be joined by Blake Schlide from the Oregon Department of Energy, who will be our main presenter for today's training. We have a wide variety of attendees for today's training, including owners and developers, energy consultants, architects, and other design professionals. And the goal of this training is to review the current commercial energy code as it relates specifically to multifamily properties. A few housekeeping notes and instructions on how to use Zoom webinar. Today's webinar will be recorded and available on our program website shortly. If you'd like to join by audio, by telephone, you can dial in at the number listed on the screen, but otherwise you should be able to join audio via your computer. And all attendees are currently muted, but if you would like to ask a question, we definitely want to hear from you. You can do so via the chat or Q&A window in the Zoom panel. If you'd like to ask a question live through audio, you can also raise your hand and we can unmute you. We'll do our best to answer questions in the order that they are received. So as a reminder, this webinar is part of a series of trainings geared towards supporting program participants and multifamily professionals. We cover topics relevant to both existing buildings and new construction projects. I'd encourage you to check out our program website for a library of past trainings. Includes recorded content on topics ranging from high performance ventilation, ductless heat pumps, and more. And also to register for our monthly newsletter to stay updated on future trainings that will be announced as well. And today's trainer is Blake Schlide. Blake serves as a facilities engineer with the Oregon Department of Energy, providing technical expertise for a number of ODO programs. Blake is a licensed mechanical engineer in Oregon. Blake is the lead for ODO's role with commercial energy codes and standards and serves on the Construction Industry Energy Board, working together with stakeholders in the Building Codes Division on energy code issues. He also works with state agencies and schools to assist with energy efficiency for new facility design and retrofits and to track and reduce energy consumption. Blake also provides technical analysis for other ODO programs such as the Renewable Energy Certificate or REC program, and he's currently involved as the facilitator for the State Building Environment Energy Efficiency Working Group, which is a collaboration of state agencies working to implement Governor Brown's Executive Order 1720 for accelerating efficiency in Oregon's built environment. So thank you, Blake, for joining us today. So here is our agenda for today. Before I pass it on to Blake, I'll start off with an introduction on the OHCS Multifamily Energy Program, also known as ORMEP for short. I'll provide context on why the code is relevant to the program and also provide some key energy code considerations as it relates to the program. Then I'll pass it off to Blake, who will provide a more detailed overview of the 2019 Oregon Zero Energy Ready Commercial Code. So to start off with ORMEP, the introduction, we'll begin with a program overview and review the program pathways, followed by the key energy code considerations for the program. So many of you on the training today are familiar with the program and have projects enrolled, but as a reminder for context on why we are putting on this training, the OHCS Multifamily Energy Program provides incentives for energy efficiency measures that result in electric savings, including HVAC measures, envelope improvements, water heating upgrades, and lighting and appliances. The program serves both existing buildings and new construction multifamily properties. Today's training on the Energy Code is targeted towards new construction projects that are required to follow the state energy code. So there are 3 program pathways for both existing building and new construction projects, each aimed and suited to varying scopes of works. The incentives escalate to reward more comprehensive design strategies. So the first 2 pathways, menu and bundle path, those feature energy efficiency measures that can be selected from a measure menu with set incentives. The whole building path is for projects doing comprehensive energy efficiency upgrades across the building. This could include exterior envelope, heating and cooling systems, lightings, or appliances. And this pathway offers the highest incentive for projects and requires a bit more effort and time, as project teams would need to work with an energy consultant who would complete an energy analysis for your property using an energy modeling tool. So this is the pathway that requires knowledge of the energy code. And for new construction or gut rehab projects, knowledge of the energy code requirements is needed for baseline modeling. This is most relevant to energy consultants who are developing the energy model for the whole building path. So to dive into more details on the whole building path, here is the incentive structure for the new construction whole building path. There are 3 incentive tiers, and the savings thresholds are relative to the percent of kWh savings compared to a code baseline. So tier 1 starts at a minimum of 20% kWh savings compared to a code baseline for an incentive of 80 cents per kWh saved, and escalates up to tier 2 at 90 cents per kWh saved for at least 25% savings, and tier 3 at $1 per kWh saved for at least 30% savings compared to a code baseline. So the code baseline, it's a really key component for establishing the percent savings and the resulting incentive a project is eligible for. And again, this is most relevant to the energy consultant who is completing the energy model, but it's valuable for all members of the project team, including the owner, developer, architect, and others, so they understand the code requirements both for ORMAP energy modeling, but also when making design decisions to maximize energy savings. So in the next few slides, I'll be going over some specifics on the new construction whole building path requirements and key program considerations as it relates to the 2019 Oregon Zero Energy Ready Commercial Code for baseline modeling that would be completed by energy consultants. So to meet program requirements in the new construction whole building path, projects use a baseline energy use model should follow the energy code requirements of the specific project as follows, which is projects permitted on or after January 1st, 2020 shall follow the 2019 Oregon Zero Energy Ready Commercial Code, which is also known as Chapter 13 of the 2019 Oregon Structural Specialty Code. So Blake will go into more detail, but the new code now features 2 parts of the code applicable to multifamily based on number of stories above grade. So there's first part 1, the commercial energy provisions. This is applicable to multifamily buildings 4 or more stories above grade, and it's based on ASHRAE standard 90.1 2016. In part 2 is the multifamily energy provisions, and this is applicable to multifamily buildings 3 or less stories above grade, and that is based on the 2018 International Energy Conservation Code. So for the most part, the prescriptive requirements of the 2 provisions are fairly similar, but there are slight differences in the requirements that you should be aware of. So projects should be sure to follow the correct code provision based on the number of stories above grade as required by code. So since there are now 2 parts of the energy code, the program developed a guidance table within the ORMAP energy modeling guidelines that provides a summary of the baseline energy code requirements. And these energy guidelines can be found on the program website. But here is the table that's included in the modeling guidelines, and it serves as sort of a quick reference guide for these requirements, these code requirements. And it summarizes the baseline code requirements for typical multifamily residential components. And this is based on the prescriptive path compliance of the 2019 energy code. So the table is split by the 2 code provisions that I mentioned previously that are applicable to multifamily. And Blake is going to be diving into the different code compliance path in more detail, which includes prescriptive path or performance path, but keep in mind this ORMEP guidance aligns with prescriptive path compliance. This is the code compliance pathway most projects pursue when submitting for permitting, and why we reference the prescriptive path when developing the code baseline model for ORMEP. But however, if a project is pursuing the performance path for energy code compliance path, we'd be happy to discuss on a case-by-case basis, as the performance path options vary between the two parts of the code based on number of stories above grade, and they vary between the ASHRAE 90.1 2016 and IECC 2018. So in the next few slides, I'll be sharing screenshots of this table by building component to highlight some of the key program considerations as it relates to the energy code for baseline modeling. I won't be diving into the details of each code requirement, since Blake will be reviewing that in more detail in his overview. Okay, so first up is appliances. So this would include refrigerators, dishwashers, clothes washers. There's no code requirement for appliances in the current Oregon code. But for energy modeling, you can defer to the recommended values in the modeling guidelines or other industry accepted practices if there are unique circumstances for the project. And then next for domestic hot water, since the program only incentivizes kWh savings if an electric DHW system is proposed in the building, you should model the baseline water heater as electric resistance with efficiency per code, which is noted below relative to tank volume. And one thing to note is there is no code requirement for low flow fixtures, such as shower heads or aerators, and we provide recommended values for that in the modeling guidelines. For envelope components, it's a pretty lengthy section. It includes components such as walls, floors, roofs, windows. You should follow the code requirements for each envelope component as applicable to your project. And as you can see in this table, their requirements are listed separately between the two parts of the code that are applicable to multifamily properties. The Part 1, commercial energy provisions that applies to 4+ stories based on ASHRAE 90.1 2016, and then Part 2, the multifamily energy provisions applicable to multifamily buildings 3 or less stories above grade based on the 2018 IECC. So in some instances, these requirements are the same, but they might be slightly different. And again, I'm reviewing this at a high level and not diving into deep. But just wanted to also make a note that the code requirements may also vary based on the location of the project and the climate zone it's located in. Oregon is divided by 2 climate zones, climate zone 4 and 5. And here's a map of the Oregon climate zones. Generally, any counties west of the Cascades falls under climate zone 4, and any counties east under climate zone 5. Okay, and next is heating and cooling. Since the program only incentivizes electric kWh savings, a program requirement is that in-unit dwelling units are served by electric heating systems. So when developing the baseline model, the baseline electric heating system should be modeled as electric resistance heaters, as this is the least efficient electric heating system allowed by code in the system, most often evaluated by project teams when they're considering switching to a more efficient heating system, such as packaged thermal heat pumps or ductless heat pumps. So that is the guidelines for the heating system. And then for cooling, there's no code requirement for cooling, but if there is cooling in your proposed design, you can model it. For the baseline modeling, you can refer to the code for the minimum efficiency for that equipment to claim savings. And then next for lighting, following the code requirements, which provide distinct requirements for in-unit, common area lighting, lighting controls, and exterior lighting. This table summarizes it, and I'm not gonna get into the details since Blake will touch on that. But there are different requirements for depending on the space type. And then finally, for ventilation, this is another area where you would follow the code requirements. But one thing to note is that the ventilation requirements are separate and outside of the 2019 Energy Code and can be found in Chapter 4 of the Oregon Mechanical Specialty Code. This includes requirements for local exhaust and outside air or in dwelling units and other spaces. So ventilation is an important component of the energy model and should be modeled to follow code. So that is the overview of the code as it relates to ORMAP and an ORMAP introduction. I'll pause if there are any questions. Okay, so if you have any questions, feel free to enter it into the chat or Q&A box. You can also raise your hand and I can unmute you if you like to ask a question live. I do have a question asking if the webinar will be available as a recording. Yes, we will post it on our program website after today. Okay, I'll give it a minute if there are any other questions. Okay, I'm not seeing any questions, so I will pass it off to Blake. I'm going to stop sharing my screen and let him share his content. Blake, it's off to you.
Thanks, Mecca. Let's see, I am now sharing my screen just to confirm that everybody can see it. It should be on the question break slide.
See, I don't see it yet.
Don't see it yet? Okay. Let's see. I will attempt again.
Okay, yep, we can see it.
Okay, there we go. Great. So thanks. As mentioned, I'm Blake Shalai. I'm a facilities engineer with the Oregon Department of Energy. I hope everybody's doing well and staying safe and productive working remotely. So I'm going to just kind of provide a quick overview of the 2019 Oregon Zero Energy Ready Commercial Code, also known as the OZERC as an acronym. You may have seen that. And just kind of talk a little bit about the history and the timeline for how we got to where we are with the current code. A little bit about what's changed since the last code, some of the compliance options that we have in terms of prescriptive compliance and performance compliance paths. And then also just kind of what changed and some typical multifamily considerations that might apply to the work that you do through the ORMEP program. So just kind of as a background, why do we consider energy code and efficiency? One of the things that I think surprises a lot of folks is looking at the electricity resource mix in our state. I think there's an assumption that we have a lot of, certainly a lot of renewables, and we do. That feed into our energy mix, but it's also kind of surprising sometimes to see that it's still less than half around of the total electricity resource mix that's comes from renewables, and still over a quarter of our electricity comes from coal and then other non-renewable sources. So to the extent that we can reduce the energy that we use in our buildings, we reduce our our reliance on these non-renewable sources too. So over time, we've done a really good job as Oregonians. A lot of it's due to the program work and the utility work, and the just having good design practices and kind of being a nationwide leader in terms of efficiency in buildings. And we've been able to kind of flatten Oregon's total energy consumption over time across pretty much all the sectors, flatten and even start to reduce, which is a good thing. Across residential, commercial, industrial, and transportation sectors. And then especially when you look at our per capita energy consumption over time, not just total, we've increased our state population and decreased our overall energy, which leads to pretty good decreasing slope on our per capita consumption, and we compare pretty favorably to the other states in our region too. So that's a good thing. We've increased our population by 19% over the past couple decades. Our GDP has gone up significantly, and at the same time, we've reduced our energy use. So, congratulations and good job to everybody and helping us get there. So, certainly more work to do though. So building codes play a pretty significant part of Oregon's overall greenhouse gas reduction strategy. We have statewide goals and statewide targets for greenhouse gas reduction. And the residential and commercial sectors are a significant wedge of our overall greenhouse gas emissions that would have to be reduced in order to help us reach our goals by 2050, which are a 75% reduction below our 1990 levels. So this is a chart that I kind of like to show that demonstrates each one of these wedges represents the opportunity in each of the sectors. And RCI, the kind of the yellowish wedge, is residential, commercial, and industrial energy efficiency, and building codes play a large part of that. This top blue line represents kind of the business as usual. If we just continue upon our normal business where our greenhouse gas emissions would be. The sloped brown line represents a glide path to our 2050 goals. So you can see there's a pretty significant gap between those two, but these wedges represent kind of the known opportunities where reductions are and where we can achieve them. That helps us get to our goal, but you'll also notice that there's still a remaining gap. So what that is kind of calls for is an opportunity for more innovation. Building codes being one of them, and other opportunities to help us close that gap to help us reach our goals. So kind of to that effect, and to help our state reach our greenhouse gas reduction goals, we've got an executive order from a couple of years ago, 17-20, that targeted multiple areas of reductions for the state. First one being energy efficiency and state government, state leadership, targets for new construction and building codes, which is really what's driving some of the recent code adoptions. And then also kind of targeting energy efficiency in existing buildings and affordable housing. So, why I think most of the folks on this call probably really understand the impact of buildings, that they represent 30% of Oregon's greenhouse gas emissions, and targeting reductions in buildings helps us reach our goals. There are elements of something else to look forward to, kind of look ahead to in the code that's coming as a result of the executive order, are the requirements for both solar-ready building construction and electric vehicle-ready building construction that's coming within the next couple years. Some of those dates for residential solar-ready are actually this year, October 1st of this year, and then on the commercial side for solar-ready in 2022, and then EV-ready also in 2022. So there's something to look ahead to and prepare for. And then the element of the executive order that's driving kind of the shift toward ASHRAE and the advancement of our commercial energy code is this one that targets targets alignment with the most recent versions of IACC and ASHRAE. So, and then most recently, just a couple months ago, right before all the pandemic hit, we had a new executive order, Executive Order 2004, that targets some additional kind of next phase. So the 1720 executive order kind of goes through the 2023 time frame on the code side, and then this one kind of looks beyond that. So then after we achieve those goals, what's coming next? And the directives set out in that executive order to look ahead to are a 60% reduction in the site energy consumption of new buildings, excluding transportation and plug loads and appliances, by 2030 from a 2006 baseline. So, I think our early analysis shows that we're, maybe at a 30 to 40% reduction versus that target now. So about halfway there. So we've got 3 code cycles to close the gap and get to the 60% reduction that's in there. So certainly some good reductions coming. and some opportunity for improvement over the next few code cycles before we get to 2030 to help us reach our statewide goals. So, so that kind of leads us to where we are now. We're, as a state, adopted the what's called the 2019 Oregon Zero Energy Ready Commercial Code that really just looks to, for the bulk of the code, ASHRAE 90.1 version 2016 requirements as the technical requirements of the energy code, but then also carves out the 2018 International Energy Conservation Code as the multifamily code. And the main reason for that is because the scope of ASHRAE, of the ASHRAE code within the text of that code is pretty well defined as being non-residential structures and residential structures that are greater than 3 stories. So in order to even have a code that applied to the low-rise residential market, the Building Codes Division needed to adopt something that had that scope within its code, and that was the 2018 IECC. So we're in a place now where we kind of have the 2 separate codes that apply to different different heights of buildings for the multifamily side. But I would expect that over time there will be some work to kind of redefine what the scope of the ASHRAE codes are as the state kind of more aligns with ASHRAE. For Oregon specific code to maybe only have the one code, but there'll need to be some work on the scope and administration language of the code there to get there. There are, in case you don't have, I know having just 2 whole separate sets of code documents can sometimes be a challenge for folks, particularly if you don't use them very often. But there are read-only versions of each of the codes that are available online through a search, either through the ASHRAE website or the iCodes website. You generally can't print those and can't save them, but if you just need a quick code reference, those are available, so you don't have to purchase the whole code book. So, why is the state kind of moved toward 90.1? There's a number of reasons that kind of support our move toward that code. A quicker, less resource-intensive development. It doesn't involve kind of the year to year and a half code development process that we've seen in the past. It's much more streamlined. It's more predictable. We kind of know what's coming with 90.1 because that's a consensus process that's public, where you can see the code and see the changes. So you can kind of look ahead to what's going to be published in the next version. They do a comprehensive cost analysis for every code measure that looks at cost effectiveness of each update. It's a consensus-based ANSI process supported through ComCheck. The compliance software, which is really a kind of a contingent kind of prerequisite that Oregon would need as some way to document compliance, and then ComCheck provides that, rather than have a separate Oregon code module in ComCheck that takes some time and often results in minor issues that just take working out, because we are able to just reference the ASHRAE or the IECC module in ComCheck. That makes it a whole lot simpler. It keeps Oregon as an efficiency leader by putting in a plan to update with the most recent versions of ASHRAE. It really reduces the time burden on code officials and volunteers and the code committees and boards that are really largely volunteer-based for adopting the new code. And then when it comes time for Oregon to make our certification to the federal government on our code efficiency and compliance, that becomes really straightforward. Because when we have to document that we're at least equivalent to a version of ASHRAE, if we've adopted that version of ASHRAE, that's pretty simple. So there's also the benefit of this chart kind of provides an overview of the increasing efficiency of the codes over the past decade or so. As they go down, they become more efficient on an EUI, a reduced EUI basis. And you can see that each version of ASHRAE is roughly, when it comes out, is roughly equivalent to the version of the IECC that comes out about 2 years later. So ASHRAE there's kind of a lead lag process where the ASHRAE 90.1 code comes out, and then a couple of years later, the IECC version comes out that kind of matches the ASHRAE code. So the quicker that the state can adopt ASHRAE, we get about 2 years of additional buildings that are rolled in under the more efficient code and get to lock in that efficiency with the code. So that kind of provides the background for how we got to where we are with ASHRAE as 90.1 as the state code, but also having the IECC as the alternate for multifamily. So the 2019 code updates, we're at the 90.1 2016 current. There are plans to move to 90.1 2019, but some of those dates are still to be determined. I think the original plan was to look at adopting that toward the end of this year, October 1st of this year, but I think some of that, certainly that hasn't been finalized yet, and some of that is going to be up for discussion at the energy code boards and the meetings that are coming up. And we do have a statewide alternative method that allows the 2018 IECC, kind of as we make the transition from being an I-code-based state to an ASHRAE-based code. So this is kind of the organization of 90.1 in terms of how it's set up. And today we're going to kind of focus mostly on the prescriptive requirements for envelope, HVAC, surface water heating, power and lighting, and kind of as they apply to multifamily. So there are 3 paths through ASHRAE 90.1. There's the mandatory requirements that are required through any of the paths, whether or not you're going prescriptive or performance. And then there's the prescriptive path that lists the kind of the set requirements for each of the building components. And then there's also the Chapter 11 energy cost budget method performance path that has been available. That's been kind of Oregon's performance path historically over the years. But then with the adoption of 90.1 2016, we have a new performance path. That's Appendix G, that some folks may be familiar with through some of the beyond code programs like LEED. So there are slight differences in just the way that each of the performance paths consider the baseline energy and the code energy that I'm not going to get into today, but you know, they just look at the performance and the prescriptive versus as designed components just a little bit differently. So Appendix G has kind of been more used for the beyond code paths and LEED and some utility programs and ASHRAE 189.1. So the fact that that can now be used as a compliance pathway could potentially streamline a code submittal, because you wouldn't have to necessarily develop 2 different energy models for, you know, one for a beyond code program and one for code compliance. You could have just one. So there could be some opportunity for savings there without having to have multiple energy models for different purposes. The IECC, so if you're under that pathway for the less than 3-story buildings, also has a performance pathway too. That's a little bit less defined than some of the ASHRAE performance pathways in terms of having that kind of set, the set criteria and appendix that are within the code body itself. But the way that the IECC kind of treats the performance pathway is that there's still the set of mandatory requirements, but the building energy cost shall be equal to or less than 85% of the standard reference design building. And you may ask why, you know, why 85%? Where did that number come from? Part of that is to take into account the IECC requirement, and I'll mention this later, for some additional energy efficiency package options. So IECC has kind of a menu at the end of the code that requires selection of one of those options from the menu. So that 85% is kind of meant as a buffer to take that into account. And then also just to kind of ensure that you are actually, through an energy model, going beyond the minimum code requirements, kind of as a safety factor. So now we'll talk about just some of the general updates from the last version of the code, and specific updates too. So Mecca kind of mentioned the climate zones that Oregon's in. So we're in climate zone 4C, kind of at the top left here, and 5B. So 4C is kind of anything west of the Cascades, and 5B is everything else. So the bulk of Oregon's population is in climate zone 4C. But one thing we did see nationwide, not in Oregon, but we did see a shifting of some of the climate zones where, you know, what was previously in maybe a colder climate zone is now in a warmer climate zone. We're kind of seeing a rising of each one. And climate zones are based on just weather data and how many heating degree days and cooling degree days exist in those zones. So based on new data, we're, you know, generally seeing a warming in some of the places that have necessitated and mandated a reclassification of some of the climate zones. So if you do work in some of the other, if you do work nationwide and in some other places, you may have noticed a climate zone change. So to talk about some of the envelope updates with the 2019 OZERC code versus the 2014 ORS or Oregon Energy Efficiency Specialty Code. So this table, and I'm not sure if, hopefully you can kind of see it on your screen, but certainly you can zoom in, and this presentation will be available for folks to look at. But it shows the strike through red text is the old 2014 code envelope requirements, and then the black text represents the new code requirements. And the middle column is for the residential buildings. So multifamily would be here. But you can kind of see some of the main updates that I wanted to point out. A jump from R20 continuous insulation for insulation entirely above deck to R30 for attic type roof spaces, an increase from R38 to R49. Actually, a slight reduction for mass walls above grade. An improvement, metal building, but that's maybe not necessarily applicable for multifamily. Slight improvement on some of the floor insulation requirements. And I'll also point out this is for climate zone 4C, but we saw similar improvements and similar updates for climate zone 5B also. So one big change in the past. So Oregon's had a 30% maximum window to wall ratio as part of the prescriptive requirements in the past. ASHRAE looks at a 40% window to wall ratio as the maximum prescriptive requirement. And kind of where that comes into play is, if you want to exceed that amount, then you'd have to look toward a performance pathway and try to make up that, any sort of excess energy efficiency from having more windows and more glazing somewhere else in the building. So now there's a little bit more of an increased buffer in terms of what you can have for your glazing percentages on the building if you're following the prescriptive pathway. So that's one of the probably bigger changes. It's a pretty small component of the overall table, but potentially pretty meaningful for your building design. And these are similar tables for 5B, for climate zone 5B. So in general, we saw kind of the same increases in the envelope insulation as we did for 4C. So whether or not you're in kind of path 1, ASHRAE 90.1, or path 2, the 2018 IACC, there's a lot of similarities pretty much across the board for the envelope insulation requirements. We kind of see that once one of the codes adopts it, the other one will adopt it too. So over time, those two codes are becoming more and more similar between the two. But there still do remain some differences between them. And I think the table that the program put together really does a good job to highlight what some of those differences are. But I'll kind of look at those here just briefly too. So where the text here is in green, that represents kind of bolded green, where the requirement might be a little bit more stringent for one code versus the other. So the IACC has a little bit more stringent requirements for mass walls, mainly because it just looks at climate zones 4 and 5 together, where their requirement matches what ASHRAE has for climate zone 5, but ASHRAE's climate zone 4 requirement is a little bit less stringent. Similar requirement or similar feature for steel framed buildings, that the climate zone 5 requirement in ASHRAE is a little bit more strict than both the climate zone 4 requirement in ASHRAE and the IACC requirement. Wood framed walls has just a little bit subtle differences between the two codes to be aware of. Same thing on below grade walls, where the ASHRAE is just a little bit more stringent. And then same thing on mass floors as well too. So where we've seen kind of the two codes are becoming more and more identical and concurrent, but there are still some subtle differences and nuances for the envelope to be aware of, whether or not you're working in part 1 of the code or part 2. So again, some subtle differences in slab on grade floors too, in terms of what the requirements are for both unheated and heated floors. So both codes do require vestibules, but they have slightly different exceptions. So depending on your building size and whether or not a vestibule would be required in that space. So in both codes, doors opening directly from a sleeping unit or dwelling unit are not required to have vestibules. In the ASHRAE code for building entrances, general space building entrances, the code threshold is a little bit smaller. It's 1,000 square feet of gross conditioned floor area. So really, any buildings that have conditioned floor area over 1,000 square feet are required to have that vestibule in there. IACC is a little bit more relaxed in that requirement, so it's in that doors open directly from a space less than 3,000 square feet, or exempted from the vestibule requirement. I will say that, so the ICC does have a provision for air curtains as an alternate to vestibules. It's not expressly listed here as an ASHRAE requirement, but Oregon does have a statewide alternate method that allows for air curtains in place of vestibules. So that kind of covers the general overview of the differences in the two codes, Part 1 and Part 2, for the envelope side. Now we'll kind of get into the HVAC requirements and what was updated from the 2014 code, and what some of the main changes have been.
Like, before you move on to HVAC, we had a question on the envelope side of things.
Yeah.
The question was, is there a state-approved UA calculator or at least U-factor calculator for path layer analysis of walls, floors, and ceilings?
Yeah, so there's not. There's where we had that kind of simplified trade-off method in the past. There's not really that same sort of simplified trade-off. But if you are if you've worked in ComCheck with the new selection, like if you select the ASHRAE 90.1 2016 code, you may have noticed that ComCheck kind of behind the scenes does kind of that trade-off, kind of a building, really a building energy model after you put in all of your envelope characteristics that will, really for every building, whether or not you're doing prescriptive or not, it'll do it. It'll do that calculation and that kind of energy model, really a behind-the-scenes energy model for that for the envelope trade-off, where you'd be able to maybe relax your envelope insulation requirements on one element, but increase them on another. And ComCheck will show you whether or not you've complied from a whole envelope perspective. So.
Great. There are no other questions. Thank you.
Okay. So moving on to some of the ASHRAE HVAC requirements. So the kind of the pathway for compliance is a little bit complex, but so ASHRAE in general, requires compliance with the different sections of the code for lighting, envelope, HVAC, and just focusing on the HVAC section now. It requires, there's general requirements in section 6.1, submittal requirements and efficiency tables that need to be followed for any pathway, and then plus one of the following. And there's a new introduction of a simplified approach for HVAC, and this is for simple buildings under 25,000 square feet that really don't have complex HVAC systems. So if you are able to follow this pathway, and there's a number of criteria and prerequisites that need to be met, you would kind of bypass some of the other code requirements. So this could be a potentially streamlined and simplified way to comply with the code. But if you don't fall under those simple performance, the simple path criteria, then there's the requirement for, there's mandatory requirements in the code that need to be followed, whether or not you're going prescriptive or compliant. So we'll kind of go through each one of these pathways today. So the simplified path is available for systems and buildings that meet a certain criteria, really for 2 stories or fewer, floor area less than 25,000 square feet, and each HVAC system complies with a set of these requirements. So. It's really just geared toward buildings that have simple single zone systems. This simplified path is not available in the IACC, though. So just one thing to note. And And so now, if we are following this kind of this the 6.4 mandatory and then down to the prescriptive requirements, we'll talk over some of the mandatory provisions. And these are important to keep in mind that they're required whether or not you're doing a performance pathway or not. They're something that needs to be included with every building. So in terms of general HVAC equipment efficiencies and what changed from the 2014 code, there were really general updates across just about all the types of equipment that are in the code. These are pretty much the same as a lot of the federal minimum efficiency requirements. But they're just duplicated in the ASHRAE book too. We saw efficiency increases for packaged AC, heat pumps, terminal AC and heat pump units, boilers, and VRF systems. There's a new efficiency table for dedicated outdoor air systems. The previous Oregon code was mostly from the 2013 version of ASHRAE, so we've seen updates here too. And then if you're under part 2 of the code, the IACC, generally matches the ASHRAE code there too. They kind of update concurrently with ASHRAE and make sure that there's alignment there. Similar requirement that we've had in the past for load calculations. It can't be just rule of thumb. It's got to actually be calculated according to engineering practices and this ASHRAE standard. And then there is a new requirement for pump differential pressure head to be determined in accordance with generally accepted engineering standards. So no more just guessing, I guess. Zone thermostatic controls, similar requirement. Really in the past for individual zones to be on their own thermostat, with the consideration that dwelling units, so for multifamily, are permitted to be considered as a single zone. One thing that I wanted to point out here in the ASHRAE codes, where we have a lot of controls-based requirements. So for example, for deadband, where there's the same controller used for both heating and cooling, there's got to be a 5-degree deadband between when heating and cooling kick in, so that you don't have a lot of back and forth, almost simultaneous use. There's now the language in ASHRAE for the controls to both be, where in the past you just saw capable of, now there's language for capable of and configured to. So a lot of controls can be capable of something, but whether or not they're set that way on day one, only to be, usually how it's set and programmed on the first day is probably how it remains. So if they're not configured to achieve those, the energy code requirements from the first day, they may never be. So now there's kind of this change and this shift to both capable of and configured to. So that could be something that that gets looked for in code compliance. There are some some slight differences in the off-hour control requirements that we have from what we previously had in the 2014 code, in terms of automatic shutdown and setback controls, and optimum start controls. So these are probably more applicable to some of the common spaces in a multifamily building, and not necessarily to the dwelling units themselves, but where you may have a lobby or a common use space. Something to point out too, not necessarily super applicable to multifamily, but there are some new increased requirements in hotels, being able to turn off both the HVAC equipment and ventilation equipment based on whether or not those spaces are occupied. So something just to be aware of if you do work in that space. For shut-off damper controls and leakage for outdoor intakes and exhaust, we actually saw a slight relaxing of the requirement for leakage rates, where before there was a requirement for 4 CFM per square foot of maximum leakage for these dampers, and that's actually increased to 10 CFM per square foot for motorized dampers. So something to be aware of with the new code. Ventilation fan controls, any fans with motors above 3/4 horsepower should have automatic controls complying to turn the fans off when they're not required. These can be on time schedules, occupancy sensors, manual timers, or a security system interlock. But there's an exception there unless they're intended to operate continuously. So ventilation fans that are required to operate continuously don't need the requirement to turn them off. If you do have any sort of enclosed parking garage, parking garages attached to a multifamily space. There's still similar requirements to automatically detect any sort of contaminant levels and then to reduce airflow if you can by either staging the fans or modulating the airflow to rates that are 50% or less of the design capacity, as long as those acceptable contaminant levels are maintained. There is an exception for smaller, really garages under 30,000 square feet. So the garage has to be pretty large to necessitate this requirement, and have no mechanical cooling or heating. On heat pump auxiliary heat control, so where you have a heat pump and then the electric backup heat, really similar requirements, and requires heat pumps with internal resistance heat to have controls that prevent that supplemental heat from kicking on. And the purpose there is to use the heat pump as much as you can without having to go toward the electric resistance heat. Demand controlled ventilation, mostly the same requirements as before with some slightly different exceptions, generally applies to any spaces that are greater than 500 square feet with a certain occupant density of 25 people per 1,000 square feet. So this might apply to some of the common spaces or maybe gathering areas in a multifamily space. So heated or cooled vestibules. This is a new requirement where we talked about the requirement for vestibules before. So now where you do have a vestibule and it's heated, it's got to have the ability to automatically turn off that heating when the outside air temperature is greater than 45 degrees, with a maximum heating set point of 60 degrees and a minimum cooling set point of 85 degrees. So just some limitations there on how much you can heat or cool that vestibule space. One new requirement too in the new code is that it actually specifies where DDC is required for new buildings and for alterations and additions. So if you meet this requirement for the applications, either for an air handler, chill water or hot water plants, and you're over these qualifications, DDC actually is a requirement for that space. So you may notice some of these slides have a star on the bottom right-hand corner, and that just represents what I think are probably some of the bigger updates for the code. And then where DDC is required, it's got to have the capability for monitoring certain zone and system demand parameters, such as fan pressure, pump pressure, heating, and cooling. And then one of the other criteria here is the automatic detection of the zones that might be excessively driving the reset logic, and might be kind of controlling or dominating how that system's being controlled, and then to provide the ability for the operator to remove those zones from the reset algorithm if they're driving that reset and causing increased energy consumption. So where you do have a larger chiller, and maybe not super applicable to multifamily, there's the requirement for monitoring of the electricity use and the efficiency, so the kilowatt per ton of that chiller. And we'll talk a little bit later about where economizers are required to, but there is a requirement for where you do need an economizer. They have to have the ability to detect a fault for that economizer. We know that economizers are one of those things that they get installed, and they may work great on day one, but then something happens, and it's not necessarily something that the operators or the building occupants are aware of if they stop working. And particularly in our climate zone, economizers are a great opportunity for energy savings. And if they're not working right, the building's missing out on a great opportunity to reduce their energy consumption and their costs. So there's a new requirement in the code to provide a fault detection and diagnostic system, FDD, that really is geared toward just being able to tell the building operator how that economizer is working, and monitoring its performance, and to be able to kind of sound an alarm or to provide a notification if something's wrong with its operation and needs to be checked out. So let's see, HVAC duct insulation. A lot of generally the same requirements, but now it's based on location, and whether or not it's a heating or cooling duct. Generally an increase from R5 to R6 for any ducts that are in unconditioned space. But slight just determination or depends on where it is and the climate zone. HVAC piping insulation, just wanted to point out that we have the same table as before. So really no updates there. So those all those requirements that I've covered up till now represent the requirements for the mandatory requirements, whether or not you're going prescriptive or you're going performance. So now we'll talk about some of the requirements that are part of the prescriptive path of ASHRAE 90.1. So here's kind of where we are in the flow chart under section 6.5. So economizers, we have generally the same threshold for economizer requirement, anything greater than or equal to 54,000 BTUs per hour. But there are lots of exceptions to that requirement. One of them, particularly in the multifamily space that I wanted to highlight here, that systems that serve residential spaces where the system capacity is less than 5 times the requirement listed in this table 6.5.1-1 are accepted from the economizer requirement. So anything that's less than 5 times this 54,000 BTU per hour requirement that serves only a residential space would not be required to have an economizer. There is a new exception also in the ASHRAE codes for if you do require an economizer, but wanted to instead of having that economizer increase the efficiency of the unit, you could do that. But if you're under Part 1 of the ASHRAE code, it requires a pretty significant increase of the efficiency, so of the SEER or the EER rating of a unit. For climate zone 4C, it's a 64% increase, and 5B, it's a 59% increase. So that's a pretty significant increase if you were trying to follow that pathway instead of putting in an economizer. If you're under Part 2 of the Energy Code, the IACC has a similar exception, but the efficiency requirement is nowhere near as high. And I should have put it in here, but I think it's around 10 or 20% of an efficiency improvement in order to get around having to have an economizer. And then so where you do have an economizer, the new code and ASHRAE actually specify how that economizer needs to be controlled, and some of the upper limit, high limit shutoffs for that unit. And then also where you do have an economizer, it's got to be interlocked with the mechanical cooling to provide that partial cooling, partial free cooling, even when some mechanical cooling might be required for that space. Let's see, other HVAC requirements, fan system power limitation really still applies to systems with the total fan horsepower, nameplate horsepower greater than 5. Some slight changes in the way that pressure drop adjustments are considered there, but really mostly largely the same requirements as before. We do have a new requirement for fan efficiency in the new code. So fans shall have a fan efficiency grade of 67 or higher, with a number of exceptions in there too, particularly for fans that are under 5 horsepower. So, and then also regarding fans and fan control, the requirement before for the ability to have variable speed on fans was really limited for DX units that were over 110,000 BTUs per hour, or for non-DX units, so for your air handlers, anything over 8,000 CFM was required to have some ability to reduce the fan speed. The new requirements are less than that, so any DX units that are greater than or equal to 65,000 BTUs per hour, and then any chill water or evaporative fans for any capacity for fans that are greater than 1/4 horsepower. So, and then depending on kind of how the temperature control is done, how far you have to reduce that the fan speed and the minimum power at that level. So, where you do have VAV systems and static pressure sensor, there's now a requirement to locate that sensor such that the set point is less than 1.2 inches water gauge. And generally for the VAV set point reset, where they used to apply for systems with a total horsepower over 10, now that's systems with a total horsepower over 5. And with the clarification that for control requirements and a requirement that alarms for zones that excessively drive the reset logic that could be potentially faulty to make those more apparent. There's the new requirement too in the code that any fans between a 12th of the horsepower and 1, so these fractional horsepower fans, have either an ECM or a minimum motor efficiency of 70%. So where you, for ventilation design, there's now the kind of an upper limit for the maximum ventilation that you could have. I know there's sometimes a desire to increase the ventilation in a space, but now the energy code specifies that the outside air ventilation systems need to meet one of these 3 criteria: either design ventilation limited to 135% of the required minimum outside air rate. And where that 135% comes from is that kind of takes into account some of the LEED credits that LEED gives for increasing your outside air, which can be a good thing, and which I think LEED provides up to, if you increase it by 35%, you can get some credits there. So it still keeps that into consideration, but doesn't allow you to go above that 135% level. Or you can have the ability to dial back the outside air rate to the minimum requirements with a single set point adjustment, or exhaust energy recovery would also be a way to comply with this. There's a new requirement for chill water pipe sizing that gives maximum flow rates for various pipe sizes. And what this really aims to do is to reduce the pumping horsepower. So you can't undersize your pipes and lead to excess friction and kind of ongoing pump head that's needed to overcome that friction. Where you do have a chill water system in a space, there's new requirements for a minimum 15-degree delta T across that coil and a minimum 57-degree leaving water temperature at design conditions. So this, again, helps to reduce the water flow through these coils to lead to less energy consumption. So energy saved by delivering the same cooling with less water flow there. Your cooling towers need to be able to have fan speed control, where before anything over 7.5 horsepower, that's now been reduced to anything over 5 horsepower. Needs to be able to throttle that fan speed to reduce, or just based on the water temperature. So on energy recovery systems, this is one kind of bigger change with the new code. We've always had the requirement for energy recovery, where before it was for any systems that were over 5,000 CFM and greater than 70% outside air. Now we've actually seen a slight relaxing of that requirement, where if there's any systems that are operating less than 8,000 hours per year, there's no requirement in the code for energy recovery. But for systems that are over 8,000 hours per year, the requirement is based on the airflow and the outside air percentage. And you look to this table 6.5.6, 1-2, for whether or not you're required to have energy recovery. So based on your outside air percentage and then your CFM would determine whether or not you're required to have that. So what that leads to is some cases that would have been required to have an ERV before may not now, and vice versa. And there are still a number of exceptions to this requirement. So heat recovery for surface water heating, where you may have a larger chill water system that has a heat rejection capacity greater than 6 million BTUs per hour, you're required to recover that for surface water heating. But there is a requirement for 24 hours per day facility operation now before that requirement applies. So this is an item that could be potentially applicable to some of the multifamily spaces. There's a new requirement in the ASHRAE code for door switches to disable the HVAC system when the door's open. So this could apply to like a patio door, a residential patio door, where if the door's open, to disable the heating or adjust the set point to 55 degrees within 5 minutes, or to disable the cooling or adjust that set point within 5 minutes. So potentially applicable to like a patio door or a deck door type space. Doesn't apply to doors that automatically close, spaces without a thermostat, or alterations to existing buildings or to loading dock type spaces. So, after all the kind of technical requirements of the code, for submittal related requirements in the code, previously Oregon had a requirement for system balancing and for construction documents to specify delivery of O&M manual to the building owner. Now there's a little bit more detailed requirements in the code for what needs to be on the construction documents themselves. But generally, so for buildings over 50,000 square feet, there's got to be detailed construction or commissioning instructions for the HVAC systems on the plans themselves. But that's really the general requirement, to be on the plans and to be kind of delivered to the owner. But there's not a requirement for that to be part of like the code compliance process. So the commissioning isn't really something that the code official themselves could look for and require a commissioning report before issuing a certificate of occupancy. So that kind of covers all the HVAC requirements. Maybe now's a good time to pause and see if there's any questions on HVAC and some of the new requirements in the code.
Okay, I am not seeing any questions in the Q&A or chat box, but if you'd like to, I'll give it a minute if anyone has any questions. If you'd like to ask a question live, I can also unmute you if you want to raise your hand. Okay, I'm not seeing any questions come through, Blake. Okay. Oh, actually there is a question. On those door open closure requirements, do they apply to common areas?
They would apply to common areas too. Yeah.
Okay. I'm not seeing any others come through. Thank you.
Okay. Moving on, just a few requirements on surface water heating. Requirements for temperature controls for adjustment of the water storage temperature. For pipe insulation, generally the old code required 1 inch of insulation for any recirculating systems, and then 1/2 inch of insulation for the first 8 feet of non-recirculating systems. The new code is mostly the same. Insulation is required for recirculating and externally heated piping, and for the first 8 feet of non-recirculating system, and branch piping too, so where you might have a branch off of a recirculating system. And the pipe insulation thickness, instead of just being 1 inch across, is dependent on fluid temperature and pipe diameter, but it is mostly 1 inch, but it could be more for hotter water or for potentially larger pipes. The new code requires automatic controls to turn off the temperature maintenance during extended periods of non-utilization. So if the water isn't being used in a recirculating system, to be able to turn that off. Last code had a similar requirement, but also required demand sensing controls and had an exemption for smaller systems. Similar requirement for heat traps. Similar requirement for pool heaters and pool covers and time switch for any sort of pumps. One difference, so where there is there might be a pool or something in a multifamily space, there was not the same requirement in the ASHRAE code for indoor pool heat recovery as there was in the 2014 code. So that's one area where it might have gone backwards a little bit. Although that will probably be picked up in the next version of the ASHRAE code. So for larger, high capacity surface water heating systems, anything over 1 million BTUs per hour is required to have a weighted average thermal efficiency greater than 90%. So, where the code itself can't necessarily require individual units to be greater than 90% efficiency due to federal preemption on some of those individual unit efficiency requirements. Where you have a larger system, that system as a whole has to be greater than 90% thermal efficiency. So some units can still be non-condensing, but in general, it requires some units to be condensing in order for that overall weighted average to be greater than 90%. So one exception there is equipment that's installed in individual dwelling units is not required for that. So that's the service water requirements. On the power side, I did want to just highlight one of the new requirements in ASHRAE that is not in the 2018 IECC and wasn't in the last version of the code, and not super applicable to like individual dwelling units, but potentially for some of the other spaces in a multifamily building that require, because this is one of the I think kind of bigger changes in the code. There's a requirement for automatically controlled receptacles. So for plugs, so for greater than 50% of the receptacles have to have the ability to turn on and turn off during unoccupied periods. Only for certain space types. So for private offices, conference rooms, printing, copying, break rooms, classrooms, and individual workstations, it requires half of the receptacles to be able to turn off and kind of go into to a non-occupied mode, where anything that's plugged into those receptacles would also be turned off. So this is to kind of start to address the plug load component of buildings within the energy code. That was one thing that the code really hasn't, or is kind of outside of the scope of energy code, or the plug loads, and this goes part of the way to addressing that, and to kind of go kind of on a separate but related item here too. Mecca was mentioning earlier some of the like appliance requirements and some of the allowances in the program, the ORMET program, for those. So appliances are generally outside of the energy code itself, and are not regulated there. And a lot of appliances have a efficiency standard at the federal level. And if they do have a standard at the federal level, states are generally preempted from having a state standard for that. Although our agency, the Oregon Department of Energy, does have the ability to kind of set state standards where they're not federally preempted. And we're actually going through that process now of adopting, as part of the most recent executive order too, at least 10 new state standards for some equipment. And some of these might apply actually to the multifamily space. And those include computers and computer monitors, faucets and shower heads, to set a maximum flow rate for those. Residential ventilating fans, so your bathroom and utility fan, requiring to be Energy Star, and electric storage water heaters to have a demand response capability. So those are just a few things that are kind of outside of the building code, but potentially related to the multifamily space, that are being worked on and considered and kind of in process right now at the state level for state energy efficiency standards. So something to kind of be aware of. So there's requirements where you do have to have automatically controlled receptacles to be able to turn those off, and based on a time of day controller or occupancy sensors. And again, this is a requirement in the ASHRAE code if you're under part 1 of the energy code, not a requirement in the 2018 IECC though. Also in the ASHRAE code is a requirement for measurement devices to be able to submeter different end uses within a building, and to be able to monitor both total electricity, the energy of HVAC systems, interior lighting, exterior lighting, and receptacle circuits. But one big note here is that there are some exceptions to this requirement, and dwelling units and residential buildings with less than 10,000 square feet of common area are exempted from this requirement. So, so certainly some multifamily spaces wouldn't need to be part of this requirement. And the idea there for exempting the dwelling units is there could be potentially privacy concerns with monitoring individual and individual energy consumption and making that visible to other folks. So that kind of covers the bigger power system updates. And I'll go into now some of the lighting updates and the changes with the most recent version of the code. So in general, across the board, we saw some pretty significant reductions in the lighting power density allowances that are part of the code. And those are primarily based on the improvements that we're seeing that are really attributed to LED lighting and those technological improvements that have happened just over the past few years. Reduction in the exterior lighting power allowances. LPDs were reduced in general, but actually for multifamily, there was an increase, which I think might have been one of the only ones, if not the only one, that saw an increase in the lighting power density. But just for example, offices LPD reduced from 0.91 to 0.79, but multifamily spaces, so for the common spaces in multifamily buildings, if you're using the building area method, increased from 0.58 to 0.68. So this is the way that the lighting chapter is kind of organized within ASHRAE 90.1, where there's general applications, compliance, mandatory provisions. Then there's the building area method, which is one of the alternatives, and then the space by space method for compliance. So we'll talk about those a little bit. For dwelling units themselves, the ASHRAE code, so part 1 of the code, requires that not less than 75% of the permanently installed lighting fixtures have an efficacy of at least 55 lumens per watt, or a total luminaire efficacy of 45 lumens per watt. But one notable exception is that any lighting that's controlled with dimmers or an automatic control device is not part of this requirement. So this represents an increase where before we had a 50% requirement for high efficacy lighting. If you're under the ASHRAE code, it's now 75%. But if you're under the 2018 IACC, it's actually up to 90%. So 90% of the permanently installed lighting fixtures shall contain only high efficacy lamps. And then what does high efficacy mean? I've also included the definition of that within the code here. So that's dependent on the lamp wattage, but generally 60 lumens per watt for anything over 40 watts, 50 lumens per watt between 15 and 40, and 40 lumens per watt for 15 watts or less. So some pretty significant changes there for the dwelling unit lighting requirements in the code. So I mentioned before that we saw really an increase in efficiency and decrease in the lighting power density watts per square foot across the board for different building area types using the building area method. And this table demonstrates the changes and the reductions, where the red strike through is the old code requirement. The black text is the new code requirement, and multifamily again has a requirement of 0.68 watts per square foot. And just a note too, the building area method lighting power densities are the same between the ASHRAE code part 1 of the OZERC and the 2018 IACC part 2. So then, after you've looked at the lighting power densities, the ASHRAE code does kind of have a new table to demonstrate the controls requirements for any type of space within the building. And then the way this is now structured is it kind of outlines the space types on the left side here. And then for that space type, you would then look across, and it shows the space by space lighting power density if you're using that method, that allowance, and then the controls requirements here. So where it says rec, any of those requirements are required for the space. Where it says add 1, you need to pick one of the requirements that are labeled as add 1. Then where it says add 2, you need to pick another one of those requirements that are labeled as add 2. So just kind of a different way of presenting the controls requirements for each space. And then the different controls schemes that may or may not be required based on whether it's listed in the table include local control, manual on, partial automatic on, bi-level lighting control, daylight response for both side lighting and top lighting, automatic partial off, automatic full off, or scheduled shut off. So this table was in the program guidelines here too, but just to kind of provide an overview of the space by space method LPDs for each type of space that might represent a common multifamily space type. One additional kind of new element in the 2016 ASHRAE code was this definition of a secondary daylight zone for additional daylighting requirements, where before we really only had a consideration for this primary daylight zone. So there's definitions for what now constitutes a primary daylight zone that's closer to the glazing, and then a secondary daylight zone that's might still be able to benefit from daylighting, but maybe not to the extent of the primary zone. And then there's controls requirements for whether or not a space is for the lighting that's in that primary zone or in the secondary zone too. So something to consider. And this really applies to the kind of common type spaces in a multifamily building, not necessarily to the dwelling units themselves. We did see some increases in the parking garage controls requirements and exterior lighting controls requirements in the new code. So this could potentially be applicable to any sort of attached parking garages for a multifamily space, where the parking garage has to have the ability for automatic lighting shut off and reducing the lighting power to a minimum of 30%, but no activities detected within a defined lighting zone that has a maximum space of 3,600 square feet, and to reduce the power at least 50% in response to daylight for luminaires that are kind of around the perimeter of a parking zone. And this graph just kind of, this image just shows kind of some of the general requirements here, where you've got to have the maximum 3,600 square foot control zone to be able to reduce the lighting when there's no one in the space. Some allowances for daylight transition zones, where you don't need to control it as much in those spaces, and then a 20-foot daylight control zone to be able to reduce the lighting a little bit there for the perimeter spaces. So that kind of covers the lighting. I'll talk about the ICC additional efficiency package options, and then see if there's any questions. So one element that, if you are following the part 2 of the OZERC, that is not in ASHRAE but is in the ICC, the ICC kind of requires a selection of one of these 8 additional measures in order to comply with the code. So section C406.1 requires that buildings shall comply with one or more of the following. So you've got to either pick more efficient HVAC equipment, reduce lighting power density, enhance lighting controls, on-site renewable energy, provision of a dedicated outdoor air system, high efficiency surface water heating, enhanced envelope, or reduced air infiltration. So you've got to pick one of those additional energy efficiency measures in order to comply. So kind of a menu-based approach, where the ASHRAE code does not have that sort of pick one requirement at the end. So something additional in the I codes that would not be in ASHRAE. So I'll pause there and see if there's any questions now, before I just get into a brief overview of compliance documentation.
Yeah, we do have one question, but just a reminder, if there are any questions, you can enter it into the chat or Q&A box, and you can also raise your hand and I can unmute you. So the question we got, it's related to when you were going over the dwelling unit lighting. The question is, do you know if those lumens per watt are the same in definition for the residential code? I think Washington State Energy Code for res is 65 lumens per watt.
That's a good question, and I would have to look. I don't know off the top of my head. I think there's alignment, but yeah, I'm not sure. I can look and I'll respond.
Okay.
Yeah.
We can follow up when we post it on the website as well.
Yeah. Good question.
Okay. I'm not seeing any other questions come through or raise hands, so you can continue.
Okay. So for compliance documentation, kind of as I mentioned before, having the ability for ComCheck is really important for Oregon to be able to document compliance there. And where in the past you may have, or you would have selected the 2014 Oregon code kind of as its own module in the code, in the software. Now you would select either ASHRAE 90.1 version 2016 if you're under part 1 for buildings over 3 stories, or the 2018 ICC. if you're under Part 2 multifamily. And I think ComCheck still might give you a prompt and like make sure that you're selecting the right code. And it might still, if you list a project in Oregon, it might still want you to select the 2014 Oregon code. But just to make sure that you are selecting either the ASHRAE code or the 2018 IACC, because those are in effect now. So then in addition to having your ComCheck forms and that's submitted, there's also the Oregon Zero Energy Ready Code Compliance Form that requires, it's a one-page form. Requires you to say which path you're following, whether or not you passed in ComCheck, and then the projected energy use of the building, along with the amount of renewables that would be needed to offset that energy use. So one of the questions that I think folks have asked the most on this is like, what do I need to do? Like that's a lot to estimate the energy consumption of a building. Does that mean I need to do an energy model for every building to be able to do that? The answer to that is no. There is the zero code energy calculator allows you to put in just some really basic characteristics of the building, including the building's type, number of floors, and the square footage. And those are really the three criteria that you need. And then it will output the projected typical energy use of that sort of a building. And that's based on some of the PNNL and Pacific National labs and the national models that have been done for the different space types. So you can definitely feel free to use that zero code calculator. And then that calculator itself will also allow you to pick like the default PV characteristics, and it has the PV watts system running in the background that'll estimate based on your building footprint size the amount of energy that it could potentially generate there. So the whole exercise could be as little as a 5 to 10 minute exercise of just plugging those numbers in and then taking the output of that program. So something to really to know and understand that it doesn't involve like a full like comprehensive energy model with a detailed analysis on the solar feasibility of a site. It's really just using that zero code calculator to plug it into the form. And the reason there is to kind of raise the awareness of the building energy code's getting more and more efficient. EUIs are dropping, and some buildings could potentially offset with on-site PV and make it a net zero building. But some buildings can't, based on where you are or the height of the building or the density. So it's really just to kind of build that awareness of what's actually needed to get to net zero buildings and how close are we to getting there. So. As we mentioned before, there's now 2 different performance pathways. There's the Chapter 11 energy cost budget and the Appendix G methods if you're not going the prescriptive pathway. There's slight differences just in the way that those performance pathways are approached. The energy cost budget method, the way the proposed design impacts the baseline a little bit more, and the baseline changes with each code iteration. It kind of becomes just backing your requirements down to code minimums for the baseline. Appendix G is a little bit more complex with the way that it's set out in its baseline. It looks back to a 2004 baseline for the code, but then defines these indexes over time, and they're called building performance factors that will kind of ratchet down with each successive code iteration to improve versus that 2004 baseline. So then in order to comply with the current code, you'd have to do better than the building performance factor for that code. So you calculate the performance cost index to determine your compliance. And there's a whole suite of proposed design and the protocol for actually doing that modeling within the ASHRAE code itself. And like I said before, the Appendix G is kind of the method that beyond code programs like LEED have used in the past. So there's now the ability to potentially do one model for both code compliance and beyond code. So there's that. I won't go into too much detail on the performance pathways. That's certainly a lot there though. But this is the table that gets updated with every successive ASHRAE 90.1 code for the applicable building performance factors for different space types. So there's a multifamily requirement there at the top that would be applicable for our climate zones if you are following this performance pathway. And then I also just wanted to mention, because it's an Oregon Department of Energy program, not related to the code and not necessarily related to multifamily, but anytime that I have an audience of architects and folks that are in the community, we like to just make this requirement aware to folks. That there's a requirement for public buildings. So if you're doing any work for city or state or school districts, to dedicate 1.5% of the green energy of the 1.5% of the total contract price of the project to green energy technology, and that's generally solar, both passive and active. It now includes battery storage, and there's alternatives to that for woody biomass and for energy use efficiency. So just something that I like to put in there for folks just to be aware of, as we're generally trying to increase the compliance and knowledge of that program. So that really covers all of the code updates that I have. Happy to address any other questions if they exist now, or certainly feel free to contact me if you do have any code questions along the way too, as you're working on a project and wanted to run something by me or have a question about it. So.
Okay, great. Thanks, Blake. We don't have any questions right now, but I'll give folks a moment to enter any questions they might have in the Q&A box or in the chat box. As well, if you want to ask a question live, you can raise your hand and I can unmute you so you can say it out loud. Okay, I'm not seeing any hands raised or questions come through. All right, was that was the end?
Yeah, I think is just with our.
Okay, yeah, and so there is contact information both for the program, myself, and Blake, if you have any follow-up questions. I'm not seeing any questions come through, but thank you, Blake. That was a great overview, and thank you for your time joining us today, as well as thank you all for joining us, attendees, taking the time to review the energy code with us. We will, as a reminder, we have recorded this webinar and we'll be posting it on our website along with a PDF, so you can follow up there as well. And not seeing any questions still, so I think we can conclude there. Thank you again, Blake, and have a good rest of your day to you all.
Yeah, thank you, Becca, and thanks everyone for joining.
Thanks, goodbye.